Have you ever wondered how the internet, cloud apps, and streaming services run so smoothly behind the scenes? How do data centers handle massive amounts of information every second without slowing down? Today, we're going to explore that world together and uncover the secrets of modern data center networking. Welcome to Bluehat Cybersec Academy. The importance of data centers. Data centers are the backbone of our digital world. They power enterprise applications, cloud services, and even your favorite streaming platforms. Behind the scenes, these networks face a huge challenge. They need to handle massive data traffic quickly, reliably, and at scale. In this session, we will explore leaf-spine architecture and high availability, and touch on the trends and best practices that keep networks running smoothly. Whether you are learning the basics or refreshing your knowledge, there is something valuable here for you. Why data center networks are unique. Data center networks are built for four essential things: high bandwidth to move large amounts of data quickly, low latency so applications respond instantly, scalability to grow seamlessly as demand increases, and high availability to keep services online even when equipment fails. Why leaf-spine architecture matters? To meet these demands, modern data centers have moved away from the older three-tier network design and adopted leaf-spine architecture. In this setup, leaf switches connect directly to servers and storage devices, while spine switches connect to every leaf switch, forming the backbone of the network. This full mesh topology ensures multiple paths exist between all leaf switches, so data always has an alternate route if one path is busy or fails. The result is fast, reliable, and congestion-free data flow. So, let's talk about the benefits of leaf-spine architecture. Leaf-spine networks offer low latency because data travels through just 2 hops from leaf to spine to leaf. They're actually really easy to scale, since you can add new leaf switches without disrupting the network at all. Performance is predictable, thanks to equal-cost paths, and the architecture is optimized for server-to-server traffic. That's the east-west traffic that dominates modern data centers. Now, if we compare this with traditional networks, in the old 3-tier designs, adding servers often means you have to upgrade aggregation and core switches, which can disrupt existing connections. But with leaf-spine networks, you avoid that headache entirely. Each new leaf can connect directly to the spine, making expansion way simpler and more reliable. Speed and scalability are definitely important, but high availability is just as critical. High availability means services keep running even when failures occur. Data centers achieve this through redundancy, failover mechanisms, and, well, smart routing. So, how does redundancy work? Well, servers connect to multiple leaf switches, and spine switches are actually deployed in pairs to provide backup paths. Multipath routing, lets traffic flow along several paths at the same time, which really improves performance and helps prevent congestion. And if a router fails, failover protocols automatically redirect traffic, keeping services online without interruptions. When it comes to best practices for high availability, it's important to eliminate single points of failure, make sure failover systems are tested regularly, and continuously monitor networks to catch potential problems before they cause any downtime. Managing traffic efficiently is a big deal in data centers. Most of the traffic here is what we call east-west, meaning it's mostly server-to-server. To keep things running smoothly, load balancing distributes workloads evenly across servers and paths, while quality of service, or QoS, prioritizes critical applications so they run without delay. And, of course, congestion management helps prevent packet loss and ensures consistent performance, even during those peak traffic periods. So, data center networking is evolving rapidly. Software-defined networking, or SDN, separates control from forwarding, which allows for centralized management and a lot more automation. Network overlays let virtual networks run over the physical leaf-spine fabric, and that's just ideal for multi-tenant cloud environments. Telemetry and automation help monitor performance in real time, and, honestly, they really reduce human errors. Security is a big focus too, with microsegmentation and firewalls isolating workloads to prevent attacks from spreading across the network. Cloud providers like AWS, Google Cloud, and Microsoft Azure all rely on leaf-spine architecture for scalable, reliable networking. Enterprise data centers use solutions from Cisco, Arista, and Juniper, which are optimized for low latency and high throughput. Understanding how these networks operate can help you design, manage, or troubleshoot modern infrastructure way more effectively. Leaf-spine networks reduce latency and, honestly, make scaling pretty easy. High availability ensures services stay online even during failures. Emerging technologies like SDN network overlays and telemetry are really shaping the future, making networks smarter, faster, and more resilient than ever before. Thanks for watching Bluehat Cybersec Academy. If this video added value to your day, give it a like, share it with someone who could benefit, and subscribe for more practical networking and cybersecurity content from Bluehat Cybersec Academy. Drop a comment. We'd love to hear how you're applying these concepts in your own environment. See you next time. Stay curious, stay secure, and keep building networks that actually deliver.